Friends, in this video we are going to talk about the bitwise operator, which is our next operator in the series of operations in C, and this is of course tutorial number 15 in this series of basics of C programming. So let's start our video on the bitwise, which is first part. Before diving into the videos, first see our overview for this lecture. So first we'll see that what are the bitwise operator and why we need them, and then we'll also see that how the manipulations are done with the help of the bitwise operators, and then we'll have the explanation session also with the help of some one or two examples on each and every bitwise operators that we will be learning in the few minutes, and then at the end we'll have the coding example session also in the Visual Studio IDE for our better understanding, and we'll also came to know that how to apply the bitwise operators and what are the different scenarios in which we can apply the bitwise operators. So these are the things that will be covered in the video. So let's start the video and stay tuned with me. So welcome here. The first topic is the bitwise operator. So you can see that bitwise operator is one of the most important operators in the C programming that we have, and it is a very useful and a very handy and powerful tool also for handling different scenarios in the day-to-day life and to solve problems in the C programming. And starting the bitwise operators part, first we'll see that how we apply them. So to apply the bitwise operator, we need a minimum of one operand and maximum of two operand. That means you cannot apply the bitwise operators on more than two operands. So for example, suppose you have A and B. So there are some bitwise operators which are used to apply on the two operands, that is on the A and B both, and some bitwise operator like NOT is there, which only needs one operand. That means say if you want to apply on the A, then it will be only applied on A. Okay, that means only one operand is needed. So you have both types. First type is that you need one operand, and second type is that you need two operand. Okay, now moving forward, we'll see that the manipulations that we have talked somewhat before here. So manipulations are basically you can say as a binary manipulation, because manipulations are mainly based on the binary part. So suppose you have two operands as discussed earlier, that A and B. So suppose A and B are two operands that you have, and you want to use bitwise operators on A and B. Okay, so what happens is that, so let's say that A has some corresponding integer value, let's say 3. Okay, then and B has some value 7. Okay, so what happened in this bitwise operator, first the A. Okay, so the A value, which is 3, will be converted into binary. Okay, and then also B value will be also converted into binary. Then the bitwise operator, what it will do, it will start binary manipulation. That means the every digit, as you know that the number A in the binary language will be the combinations of zeros and ones, and same apply for the B also. So what happened, that it will take each digit of both A and B and it will start manipulating. Okay, we'll see in the examples that how this binary manipulation happens, but for now, just understand that it involves some binary manipulations, and that's why it is considered as very powerful, because it is very handy, and you can handle it in very very efficient way. Now moving on to the further, we'll see that what are the different kinds of bitwise operators. So first is the AND, second is OR, third is NOT, then left shift, then right shift, and then XOR operator. So these are 6 mainly bitwise operator that we will be using often. The first 3 are very important, and last 3 are also very important, but we will be using these 3 not very often in comparison to above these 3. So don't confuse here with the logical operators of AND or NOT. See here, that note here, that in the case of logical operators, to the AND operator is denoted with the help of 2 ampersand, but here we are using only 1 ampersand. Okay, And OR operator, we again use two parallel lines, but here only one line is there. And NOT operator, we have used exclamatory sign. Okay, so this is how the bitwise operator is different from logical operator. And also logical operators are dealing with logic only, not that much about binary manipulation. The binary manipulation only happens in the case of bitwise operators. Okay, so these are the six main bitwise operator, that is AND, OR, NOT, left, shift, right, shift, and XOR. In this video we'll be talking first three only, and in the next video we'll talk last three. Okay, so let's start our discussion on the AND operator first. So it manipulates two bits at a time, as we have discussed that bitwise operators can be operated on two operands or one operand also, but here AND operator needs two operand to operate. That means basically what it needs, two bits. That means either 0 and 1, either 1 and 0, or either 0 0 or either 1 1. So there can be four scenarios where AND operator will have to find the value. So out of those four scenarios, if both the bits are 1, then it will return 1. So suppose you have say number A and number B, and the binary representations are the combinations of zeros and ones, and if you are using the AND operator in this, then there may be scenario that you need to operate on 1 and 1. Okay, that means 1 and 1. Okay, so 1 and 1 will give 1, and otherwise if you have 1 0 or 0 1 or 0 0, then it will give 0. That means if both the bits are 1, then it will return 1. Okay, that's simple as that. Okay, now for example, consider here A equals to 1 0 1 1. So this is some number which in the binary whose representation is here as 1 0 1 1, and similarly B is also corresponds to some number whose representation is 1 1 0 1. Now if you were using A and B, then what happens is that it will start to manipulate with bitwise. That means each and every digit. So how it will work? So suppose first bit is 1 here, and for B also 1 here. So 1 and 1 will give 1. Okay, then next is 0, then 1. Okay, then 0 and 1 will give 0, as we know that it will give 1 only if both the bits are 1. Then next 1 and 0, again it will give 0, and at last again 1 and 1, then it will give 1. So you can think it as the AND gate. If you know about gates, then it is same as the AND gate operation. So if you have 0 and 0, then it will give 0. If you have input as 1 and 0, then again it will give 0. And if you have input as 0 and 1, then again it will give 0. But if you have both the inputs as 1, then it will give 1. So here a typo here it will not be okay, it will not be 0, it should be 1 here. Okay, so we'll just correct this. So this is not correct, this should be 1. Okay, so here it is 1, just think it like that. So as we have discussed till now that this is same as the AND gate. Okay, so here make sure that you understand it as 1, because 1 gives 1. Okay, 1 1 gives 1. Now this is how AND operator work. Now moving on to the OR operator, it also needs two operands to operate, and in this case if both the bits are 0, then it will give 0, otherwise it will give 1. Okay, so if you have the bit as 0 0, then it will give 1, but if you have the bits like 0 1 1 0 or 1 1, then it will give 1. It is also same as the OR gate, if you have again studied in the earlier classes in your 11 12 classes. Okay, so for example, consider again 1 0 1 1 as the A and 1 0 0 1 as the B. Make sure that you understand that this is a binary representation of a number which corresponds to A. Suppose this number corresponds to some to 8 or something like 10, suppose, then this is the representation. This is a binary representation of the number A. Okay, so if you apply A or B, make sure that you use OR operator as a vertical line here. So A or B. So if you will do binary manipulation with the help of bit by bit, then 1 or 1 will give 1. Okay, then 0 0 will give 0, as we have discussed earlier, that if both the bits are 0 then it will give 0, otherwise it will give 1. So same here, again 1 0 it will give 1, then 1 1 again it will give 1. So this is how our operator works, and you can see that the truth table corresponding to OR operator is same as the OR gate in the physics. Now at last, seeing to the NOT operator, it so here it needs only one operand, it does not need two operands A and B. So if you want to apply the NOT operator, then you will only need a single operand, let's say A. Okay, so what's the purpose of NOT operator? So it makes 0 to 1 and 1 to 0. That means whatever result you have, it will change that result. That means if you have a result like 1, then it will change to 0, and if you will have result as a 0, then it will change to 1. Okay, so suppose you have an example A equals to the binary representation of the number which corresponds to A as 1 1 0 0, then the not A will give by doing bitwise manipulation or binary manipulation or bit by bit manipulation, whatever you want to call, you can call. Okay, and then if you start this, then the not of 1 will give 0, then not of 1 again will give 0, and not of 0 will give 1, not of 0 will again will give 1. So this is how and not or operator works. I hope you understood it better. Now, to have better understanding and have a good hand on these operators, let's write some code to understand. So let's move to the Visual Studio IDE for our better understanding. So welcome to the Visual Studio IDE, as this is tutorial number 15. So we'll save it as this file as tuts15.c. Okay, so you can see we have saved this code, save this file. Now what we will be writing here, so we'll write the code to check whether the number is even or odd using the bitwise operator. So let's start the code from scratch here by writing include stdio.h. okay, it's not comma, it's pointed. Now this will be my main function. Oops, it should not be like this. I'll just do here, yeah, okay, now it's correct. Now I will do here. Now let's declare a variable as 0 as A, and then we'll print the masses for to the user to input the value. So enter the value of the A here, and then I will add a new line character, and don't forget to put the semicolon. Now I will scan the value of A here, which will be %d and ampersand. So till now I have scanned the values of X. Now let's coming to the main part of the code, which is applying a else statement here. So be careful here. So what I will be doing is that I will be using AND operator here. Okay, so AND operator with 1. I will be checking here, that check whether the bitwise operator AND which is executing in two operands, say here A and 1, whether this value is equal to 1 or not. So if this value is equal to 1, then what you have to do, you just have to print odd. Okay, that means the number is odd, so it will print odd. Else the value is not equal to equal to 1, then what you need to do, you need to printf that the number is of course even, and then new line character. So and at last we'll say everything went fine now, and then we'll do return 0. Okay, and let's save this code here, and we'll try and compile here, which is tuts 15.c. okay, so it has compiled successfully. Now let's run the code here and wait for the pop-up message asking the user to input the value of A, and we'll input two values. First will be the even and second will be the odd, and we'll see that whether the values are correct. So let's understand that why we are doing. So if you have say if you have a number odd number, and the binary representation has say some 1 or 0. Okay, so if the number is even, then the last digit of the binary representation of the a will be 0. Then if you will do 0 and 1, okay, then the value will be 0. That means if the number is even, then this value is not going to be equal to 1, and hence it will come to the else block and it will print the even. Okay, if you have odd, then the last digit of the binary representation of a will be 1, and since you can write 1 as 0001, then after manipulating the AND operator, you will find that the last digit what you will get as 1. Okay, the overall value you will get it as 1. Okay, then if it is equal to 1, then that will be odd. Okay, you can try yourself to understand this. It is very simple. You just need to write the binary representation of a, say the binary representation of a as 1110, then you need to write the 1 as 3 times 0 and last one, because that will correspond to the value of a. So now you have the two binary representation for a as 1110 and 1 as 0001. Now you can use the AND operator bitwise bit. What you will find, that you will find the value as 0001, which is equivalent to 1. So if that will be equal to 1, then that number will be odd, else it will be even. So this is how it works. Now just try giving the value, say 45 is the value. You can see it is odd, and now give value. Now again run it and give value as 4. You can see it is even. So it is working good. Okay, I hope you understood the code and how to apply the bitwise operator, and you can try printing this. You can, if you want to change the what to say, if you want to change the output, then you can just use your the not operator. So if you will be using it, then it will give opposite result. Okay, that means if the number will be even, then it will show as odd. Okay, so just try and compile. So it is compiled. Now run this code. It should ask the value of a. It will ask them. Just wait for that. So if I enter 45, so you can see that the output has changed from odd here to even here. Why? Because here this part is returning 1. Okay, because it is equal to 1. Since the number is odd, so this whole part will return 1 to the if 1, but as we have used the not operator, then it will change the 1 to 0, hence 0 will be returned to if, hence it will not execute the odd part, it will come to the else part and it will print even the number is odd. Okay, instead the number is odd, it will print even, because we have changed the output using the not operator. So this is how you can apply the concepts of the bitwise operator. I hope you understood it better. Please like this video, subscribe the channel, and don't forget to hit the bell icon, and Jai Hind.